Hello, I'm Jamie Ellis from the University of Florida's Honeybee Research and Extension Lab, and welcome to a video field guide to beekeeping. Today we're talking about small hive beetles, that pesky little critter that causes so many beekeepers across the U.S. so much misery. Small hive beetles are native to sub-Saharan Africa, where they inhabit colonies of African races of honeybees. In Africa, small hive beetles hardly cause any problem at all to bee colonies there. In fact, when small hive beetle populations build up to really high numbers, African bee colonies simply leave. They won't stay in the colony and die. Small hive beetles were really unheard of prior to the mid-1990s when they were found in the United States. In the mid-1990s, in fact, they were found in Florida, South Carolina, Georgia, and other states in the southeastern U.S. Since that time, they've spread all over the United States, and in fact have been found in Australia in 2000. Small hive beetles love to live in bee colonies. Now, they belong to a family of beetles called nitidulids, and nitidulid beetles in general like to eat rotten fruit and tree sap and things like that. Even though small hive beetles will feed and reproduce on rotten fruit, they much prefer to be in bee colonies. In fact, they locate bee colonies because they're able to smell the smell of bee colonies. They're able to cue in to the smell of pollen, the smell of honey. But in particular, there's some evidence out there that small hive beetles use a yeast in order to locate bee colonies. This yeast is present on the outside of their bodies, and when this yeast mixes with pollen, the yeast produces honeybee alarm pheromone, so that attracts other small hive beetles to the colonies. Once the adult beetles are in the colonies, the female beetles will begin to lay eggs. Interestingly, you can sex small hive beetles. If you grab an adult small hive beetle and slightly squeeze its abdomen, one of two things will happen. Either a very long appendage will come out, which is actually an ovipositor or egg-laying machine, which indicates that's a female, or a very small piece of the shell will come out, which indicates it's a male. Small hive beetles will go through bee colonies looking for places to oviposit or to lay eggs. Once she finds a crack or a crevice, she'll back up to that area, insert her ovipositor into that crack, and pivot her ovipositor around, laying eggs. In fact, small hive beetle females will even bite holes in brood cells and stick their ovipositor in the brood cells and lay eggs around the honeybee developing inside the comb. After this, the larvae that emerge from those eggs will tunnel through the colony, feeding on bee brood, they'll feed on honey, they'll feed on pollen, and there's a hypothesis out there that their excrement or their feces will cause the honey to ferment. So typical symptoms associated with small hive beetles going through the colony are the fermentation of honey. Once the larvae finish feeding in the colony, which typically takes about 7 to 14 days, they'll come out of the colony and tunnel into the ground where they pupate. Once the beetle larvae are in the ground, they will excavate small cavities where they turn into pupa. Typically, they'll stay in the ground from 21 to 35 days, all of this depending on the temperature or the moisture of the ground. Once they finish pupating, the beetle adults will come out of the ground and begin to look for another colony, as we've described already. Small hive beetle populations tend to be their greatest in mid to late summer. Typically what happens is, coming out of winter, beetle populations are really low, so it takes them a lot of time to actually build up to levels that are damaging to bee colonies. So in spring, in summer, beetle populations will grow to mirror the bee populations that are growing at the same time. Once fall and winter come around, beetles will actually go into the cluster of bees as the bees are clustering to keep warm. And the beetles will stay alive in that cluster of bees in order to survive winter. There's also some evidence that beetle pupa will stay in the ground over winter as well. When spring erupts, so do beetle populations. The beetles will come out of the bee clusters, begin ovipositing and reproducing, peaking again about mid to late summer. Small hive beetles have a very unique series of interactions with their honeybee host. Once they go inside that colony, a number of behaviors that you would find it hard to believe actually occur. Here to tell us about that today is Eddie Atkinson. Eddie's a PhD student at the University of Florida's Honeybee Research and Extension Lab. Eddie investigates the interactions between honeybees and small hive beetles, in particular how those interactions develop.
Now when beetles enter the colony, in response to aggression from the guard bees, they try to find cracks and crevices in which to hide around the periphery of the colony. And when bees find these beetles in these cracks or crevices, the bees actually station guards to keep the beetles in these prisons. And they do this to prevent the beetles from escaping and ovipositing within the colony. Now if the colony is stressed for some reason, whether it's queen issues or other pests, the beetles can manage to escape and oviposit in the colony, which helps lead to the destruction of the colony. But in strong colonies, the bees can keep the beetles in there indefinitely.
Small hive beetles don't just starve to death while they're sitting in those bee prisons. In fact, they've got a very interesting behavior where they're able to solicit food from their bee host. Take a look at this video. In this video, a small hive beetle has approached the edge of a prison, and the bee guard is standing there wanting to keep the beetle from escaping. This particular beetle has used its antenna to rub the mouth parts of the bee. Rather than the bee attacking it, it's been touched in the right spot and it begins offering food for the small hive beetle. Believe it or not, small hive beetles are able to trick their bee captors into feeding them while in prison. As we slow this picture down, you'll actually notice how the small hive beetle's antennae are very intricately massaging the mandibles of the bee. This causes the bee to regurgitate nectar or honey from which the small hive beetle just sits there and eats. After the small hive beetle is finished feeding, he or she will go right back down into prison, waiting for a chance to escape. Fortunately, small hive beetle problems are easy to diagnose, primarily because you can see the adult beetles. Adult beetles are about the size of a bee's head and thorax, and when you take the lid off of a colony, you can see them scurrying around, or if you're doing work on the bottom board or on the outer frames where beetles like to hang out. Secondly, you might see beetle larvae. Now, there really are two ways that you'll see beetle larvae. At low populations, beetle larvae tend to be very difficult to find. So you might find them on a Varroa sticky screen that you're using or in beetle traps that go on the bottom board of the colony. Usually, though, people notice small hive beetle larvae once they have frames that are decimated by the larvae and there's thousands of wiggling larvae going through the combs. Typically, when this happens, it's too late. Also, you may notice beetle presence when bees begin aborting lots of brood. This is usually a sign that beetles are ovipositing in the brood and bees are removing that brood to get the beetle eggs and beetle larvae out. All of this problem usually causes honey to ferment, and the honey will bleed out of the combs and can even bleed out of the joints of colonies. Unfortunately, controlling small hive beetles can be quite difficult because there are no silver bullets to controlling beetles completely. But fortunately, we're giving a number of options to try to minimize beetle populations in the wild. Largely that breaks down into four categories: cultural mechanical control, genetic control, biological control, and pesticidal control. So let's go through those individually and see what tools are in our arsenal to use against small hive beetles. First, cultural control. Cultural control is any change in practice that reduces pest numbers. Let's give an example. Small hive beetles are a particular problem in honey houses because there's all this unprotected honey there and beetles just go in and reproduce. There are no bees there to protect it. Beetles have a field day. So with regard to honey houses, it's very important to extract your honey within 24 hours of taking it off the colonies. If you feel that you have to leave it in the honey house longer than 24 hours, then you should probably freeze the honey to protect it from adult beetles. Another good way to control beetles culturally is just to remember cleanliness. Oftentimes, beekeepers will leave equipment or frames or dead out colonies in the apiary, and these are perfect places for beetles to breed and reproduce. So one of the best things you can do is, if you have a dead out colony, to remove that equipment from the field. Don't leave frames of honey or pollen or brood laying around. Make sure that all of this debris is removed so that you don't give beetles a place to reproduce. Another good cultural control method lies with the equipment that you use for your bee colonies. I've traveled all over the world, and I can honestly say that U.S. beekeepers keep some of the best bees in the best colonies, but we still have some problems with equipment having multiple holes in it or being cracked or broken altogether, which gives small hive beetles wonderful access to the bees within. So simply using good equipment is a very good thing to do when controlling small hive beetles. The final thing you might do when considering how to culturally control small hive beetles is to take out your weak colonies. Now, colonies that are not dead, that are weak for whatever disease, varroa mites, Cleanliness, etc., are perfect places for small hive beetles to move into and overtake. So if you ever recognize a weak colony that doesn't look like it's going to be easy to remedy, I suggest combining it with a strong colony to avoid altogether having beetles going in and reproducing. Also important in the cultural way of controlling small hive beetles is using traps. Traps are a great non-chemical way to reduce adult beetle populations. Currently, there are about 3 traps on the market that provide fairly decent control of adult beetles. The first is the hood beetle trap. Now, the hood trap actually fits into an existing frame. And these days, hood traps have 3 compartments in them. In the middle compartment, you can simply fill with apple cider vinegar, which serves as an attractant for small hive beetles. The outer 2 compartments should have mineral oil in them. So when beetles go into the hood trap, because they're attracted to the vinegar, they'll go into the mineral oil and will actually die. The good thing about hood traps is you can put multiple hood traps per colony. In the super, in the brood box, 2 or 3 hood traps per frame. They work pretty good at limiting adult beetle populations. Another popular trap is the West beetle trap. Now, the West beetle trap fits on the bottom board of a colony, but due to its thickness, you actually have to put a rim of wood on top of the bottom board, between the bottom board and the brood super. This permits the West beetle trap to be in place and bees to exit and enter the colony without a problem. In the West beetle trap, you can put vegetable oil, which simply serves to kill small hive beetles that wander into the trap. Important to remember about the West beetle trap, though, is your colonies must be level if you're using them. Otherwise, the mineral oil may spill out. Another trap that's become increasingly unpopular is AJ's Beetle Eater. AJ's Beetle Eater fits between 2 frames like you see here. You simply put oil or apple cider vinegar in it, and beetles go in because they're hiding from the bees, and they'll die when they're in those traps. Now let's talk about the genetic control of small hive beetles. I've already mentioned that small hive beetle females will oviposit or lay eggs in the brood cells in the colony. Now, some bees can detect this and actually abort the brood. You may wonder how this helps. Well, it's quite simple. In the process of removing the brood, the bees actually remove the beetle eggs and the young beetle larvae as well. So this is a good way to suppress beetle reproduction in the colonies. Biological control is another option for use against small hive beetles. Biological control rests on the assumption that there are diseases or things out there that hurt or kill small hive beetles altogether. Fortunately, research done at the University of Florida Honeybee Research and Extension Lab in cooperation with other bee institutes around the country have looked at entomopathogenic nematodes, or put simply, nematodes that eat insects, and found that there are 2 species that work very well against small hive beetles. The first being Heterorhabditis indica, the second Steinernema rheobravi. Both of these nematodes, when put in the ground around the colonies, serve as heat-seeking missiles where they seek out small hive beetles pupating in the soil. Once they find the beetle, they'll tunnel into the beetle's body, regurgitate bacteria. That bacteria digest the inside of the beetle, and nematodes feed on the resulting soup. A few nematodes go in, thousands of nematodes come out, and you've got a perpetuating system of small hive beetle control. It's important to remember, though, when you're trying to control small hive beetles, to use all of the controls I've already given you in a holistic manner. Integrate them using integrated pest management in an effort to reduce beetle populations. The goal of IPM is to reduce the pest populations below the economic threshold so that you don't have to treat. In the event, though, that small hive beetle populations increase over a certain threshold, you can use pesticidal control. And currently there are 2 pesticides used against small hive beetles. The first is Checkmate Plus with the active ingredient Coumaphos. Now Checkmate Plus is oftentimes used as a control for varroa mites. In its marketed form, Coumaphos is impregnated into plastic strips. For small hive beetle control, you cut the plastic strip in half, staple both halves underneath a 4 by 4 inch piece of cardboard, and slide that device on the bottom board of the colony with the chemical or strips facing down. Now as small hive beetles run from the bees and go up under the cardboard, they'll get exposed to the chemical and die while underneath. The second pesticidal control is Permethrin, which is the active ingredient in a product called Garstar. Garstar is mixed with water and applied around the colony. Now the Garstar will go into the ground and it will kill the pupating small hive beetles. The problem with pesticides is both of these pesticides hurt bees. Permethrin kills bees outright, so you need to be very careful how you apply it. And Checkmate Plus causes many sublethal effects on honeybees that we are only just beginning to discover. So it is very important that if you elect to use these 2 chemicals, that you follow the label. You'll notice we didn't give any specific recommendations on how to use the chemicals, how long to put them in the colony, how to apply them around the colony, because the label is the law. Pesticide labels change all the time. So it's important that if you use these 2 products, read the label carefully and follow the directions. If you do all of these things, you'll go a long way into controlling small hive beetles. But let me give you one last piece of advice. Small hive beetles are opportunistic scavengers. They work best and reproduce best in colonies that are weak for whatever reason. Whether the colony is queenless, whether it has varroa mites or nosema or some other problem, this is a breeding ground for small hive beetles. So the best way to control small hive beetles is to keep strong, healthy colonies. Beyond that, consider using traps. Remember cleanliness. Remember genetic control, biological control, and as a last resort, you can use pesticidal control. Thank you for joining us with this episode of a video field guide to beekeeping. Hopefully you've learned something about small hive beetle biology, behavior, and especially how to control this menacing pest.